commas, 0. Well, percent gets us started, but percent is not a very powerful tool when it comes to solutions, because let's say I have 3% magnesium chloride, and I want to compare that to 3% potassium bromide. Are they equal?
No.
I know they're not. I don't know if they're like that or like that, but I absolutely guarantee you they're not equal. I'll give you a choice. I'll give you $1,000, 1,000 francs, or 1,000 yen, or 1,000 pesos, or 1,000 rupees. Probably don't know which to take. Neither do I. I have no idea.
$1,000.
What would you do given that option? You would convert them all to American dollars. If you lived in another country, you'd convert them to that country's currency. You would convert them to, what's it called?
Common denominator.
Common denominator. Guys, you learned that in first or second grade. Not that we're going to do that right now, but it's the same principle. Common denominator. I'm surprised I remember how to do that. Third grade, that was back in the 40s. Maybe that was the third. I'm so old, I just get to use that as an excuse. So yeah, I don't know. I don't know. So we need a more powerful unit. Somebody likes this.
Good. Mole day's coming up.
Freaking masochist.
Mole day's coming up.
Right. It's October 23rd is Mole Day at 6:02.
As in the furry critters or chemistry?
Chemistry.
Oh, cool.
Yeah, high school, we would make little felt moles and we go around the classroom and throw moles at each other.
Oh, nice. I heard the other day was Dog Day. Somebody said it was National Dog Day.
Yeah.
I gave my dog a hamper. Okay, this is a big M. That's important because a small m means something else. So molarity is moles of solute in 1 liter of solution. Now, if we, well, one thing we want to notice immediately is that percent and molarity, we both have solution in the denominator. If we had solvent downstairs, it'd be an animal of another species. But they're very, very easy to convert back and forth between percent and molarity because we have solution in the in both. So big M moles of solute in 1 liter solution. What's a mole? You remember from biology, you remember from high school. Yeah, I heard it, Avogadro's number, 6.02 times 10 to the 23rd. You guys know how a dozen equals 12? Well, a mole equals that. And I mean, we don't have to write it that way. If you'd rather, we can write it this way. Better punctuate that thing.
23 zeros.
But I don't know. Last time I checked, I can't put that into my calculator.
No.
There's no way. And I've got a nice calculator. Hewlett Packard, the only way to go. So we have to write it in scientific notation. So yeah, a mole is just a unit, guys. It's just a unit, like a dozen. You can have a mole of students. Need a bigger room. Mole of pencils, a mole of markers.
Mole of pennies would solve the national debt.
Yeah, it would. Speaking of that, did you guys read about that guy that asked something like 2.8 million people to send him a penny? He got, I don't know how many people he asked, but he got 2.8 or so million people to send him a penny, and some of them sent him a nickel or a dime. And of course, the postage was like, whatever, I think they said 22 cents, so it was probably a while back. I don't know what it costs to mail a letter today. I'm guessing more than 22 cents. Nobody mails letters anymore, so how would we even know what it costs to mail a letter? Anyway, yeah, he got 2.8 million people to send him a penny or more, accumulated nearly $30,000. He used it to fund his college. Now, that wouldn't fund your four-year degree. That wouldn't fund your college in today's world, but it
would
did.
help.
True story. True story. I mean, who wouldn't send somebody a penny? Well, I would, but if I wouldn't pay the 95 cents postage to do it. Anyway, so instead of a dozen roses, buy a mole of roses. Okay, it's just a unit. That's all it is.
I don't think there's that many roses.
I don't think there are either.
Well, then,
But there's another, and for us, more important way to define a mole. A mole of any atom or molecule is its molecular weight in grams. So if we go to the periodic table, one mole of carbon equals 12.011 grams. So if I had 12.011 grams of carbon, I would have 6.02 times 10 to the 23rd atoms of carbon. And that's why this concept is necessary. If I'm combining two things, to make something, I clearly have a one-to-one relationship. So if I took 10 atoms of sodium and combined it with 10 atoms of chloride, I would get 10 molecules of salt. But how am I going to count atoms? I need a microscope to see cells. How am I going to count? I can't count them. I know. Let's try this. 1 gram of sodium and 1 gram of chloride. 2 grams of salt. Nope, that won't work. Why not?
Because 1 gram of sodium is not the same as 1 gram of chloride.
Yeah, 1 gram of sodium is not the same as 1 gram of chloride. Look at the molecular weights. Chloride, 35.453. Sodium, 22.98977. So that won't work. But what will work is to take 1 mole sodium, which will be 22.98977 grams. And combine that with 1 mole of chloride, which will be 35.453 grams. And that will give me 1 mole of salt, be whatever that is. And the reason that works is because 1 mole of anything is its molecular weight, but is also Avogadro's number. So I have exactly 1 mole of sodium and 1 mole of chloride, or exactly 6.02 times 10 to the 23rd atoms, and that will give me 6.02 times 10 to the 23rd molecules. Now, to be perfectly honest with you, we don't even need Avogadro's number in this class. What we need in this class is to understand that a mole is a weight. There's an interesting thing to point out here. People don't round this correctly when they round it to 1 decimal place. If you round it to 1 decimal place, it's 58.4. But the world uses 58.5 for the most part for sodium chloride. So while I did go to the periodic table and pull off all these decimal places, and typically that's what we do, with sodium, it just goes on this little index card of stuff I cannot forget. Another one that goes over here is any hexose sugar. And then they just, they don't even use the decimal places for that. Now that's not to say some people working in analytical chemistry would do it that way. But in biology and physiology, that's how we do it. In other words, hexose sugar, 6 carbons. Your hexose sugars are glucose, galactose, fructose. And they're all C6H12O6. And they just say, well, carbon 12, 6 times 12 is 72. Hydrogen 1. 12 times 1 is 12. Oxygen, look over here, 16. 16 times 6 is 96. Okay, so don't ever use up valuable time calculating the molecular weight of a hexose sugar or a sodium chloride. Just use these numbers. These are the numbers that I will have used when I fill the key. And generally speaking, students like their answers to match the teacher's key. So then with molarity, we'll do this and then we'll go. I just noticed what time it is. Calculate the molarity of a solution containing, we'll do a couple of them real quick, 2 moles of glucose and 1,000 milliliters. The answer is 2. Okay, just as I did with percent, give you, I call them mathless math questions. I like it when the math is mathless. What was I given? What do I want? I want molarity. I want to know how many moles are in 1 liter. What was I given? Oh, 2 moles in 1 liter. I said we'd do 3 real quick. Half a mole of magnesium bromide and 100 mils. So if I've got half a mole and 100 mils, 5. In other words, 100 times 10 gets me to a liter. So I have to multiply the top by 10, so I have 5. Two fourths equals 1/2. That's all this is. That's all this is. And then a third one, 4 moles, whatever, salt, just use table salt. The answer is 12. In other words, how do I go from 333.333 to 1,000? Multiply it by 3. So I multiply that by 3. 12 molar. You'll notice, guys, that in these mathless math problems, I give you numbers that are easy to manipulate in your head, and I give you things that if it's not already in the form of a liter, it's easy to get it to a liter. You know, what if over here you had 500? How do you get that to a liter? What if you had 200? How do you get that to a liter? You're saying multiply, right? It sounds like you're saying divide. Okay. I'm old, man. I'm sorry. What if you had 250? Multiply it by 4. So when you have these mathless math problems, they're designed to be bang, 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 bang. All right, we'll pick up right here, guys. Stay with me. So we'll take this and run with it on Wednesday. Who has the attendance? All right, drop it off on your way down, and let's not get up there before that, please.